Okay, we have a 15 inches. It's an A1398. Yeah, it's A1398 AMC 2673. It says it's no power. So let's see what we have. Okay, because we don't know what state the device is in, we are not going to connect power to it. First thing we do is we take out the back cover. It is not advised, especially if the device is in no power. Before you connect charger to it, take out the back cover to get an idea of what's happening inside. You don't know if it's a liquid damaged device. You don't know if it's safe to. Before you connect the charger, just be sure that you are not going to create more damage to the device with your connecting of the charger. Okay, so this is a 2012, early 2013 board. The board number is going to be 820-3332. So let's just open that. 820-332, 3432. Yeah, that's the board number, and that's the board view. So this board, it's very usually the common failure on this board is U9800. So over time, U9800 loses communication with the board, and then what happens is you get all kind of weird behavior from the machine. Sometimes the machine will work with and then you have a black screen, and the other times the machine will just not even start at all. It tries to start and then stop. So 9 out of 10, if you have no image on this machine, you should worry about U9800. The way to fix it is actually quite easy. All you have to do is just resolder U9800, and then you will be good to go. So on this one, we're not quite sure exactly what the issue is. So what you want to do is first and first, we can see that it's not a liquid damage device, and 9 out of 10 on this device is when it comes in, the one thing that you have to worry about is it's probably being a U9800 issue. So let's see what this is. Let's connect our charger. We have communication. We have fan spin. We don't have fan spin. So what we want to do is let us disconnect the battery and then see what we have on our PP box. The LED is present, which tells us that PP342, which tells us that PPDC in it's present, and then it also tells us that PP342, PP3429 is fine, because if that was not the case, we wouldn't have communication. LED will not be present on our charger. So the next thing we want to do is we want to see what we have on our PP bus. So PP bus, we can measure our PP bus at these fuses here, F7041 and F7040. So we can get to measure PP bus at either of these fuses. Here is where it says PP bus underscore G3H. So G3H basically means so what that signifies is that it's a rail that should be present at all times. Okay, let's check this. Check that again. Okay, now let's see what we have. Now PP bus 12.6. Okay, so 12.6 in our PP bus. It's yeah. Let's take the board out, but I'm pretty much sure. I mean, I can tell you that most likely this is also going to be an issue of U9800. Yeah, and as you can see, sometimes the board won't even start. That that can also be from U9800. But before we play U9800, let's first take the board out. U9800. U8900, yeah. U89, is that? Yeah, 8900. U8900. So before we play U8900. Let us first take the board out and check basic measurements. 5 volt line, say that's our 5 volt line is present. Okay, put this out. Let's put the shell aside. See, because we will be using the DC jack, so you don't have to disconnect the DC jack from the board because you need it once the board is out. Let's try to test our board. So the next thing I want to do is I want to see if our 5 volt line is present. That we can check at SLPP. So 5 volt underscore S5. Let's see if that rail is present before we worry about going to check our U8900. Okay, U8900. Okay. So let's see what we have. Connect our charger. We have charger communication. Let's see, do we have 5 volt at U7201? We can check that at this cap here, C7205. That's going to be this guy here. So let's see, what do we have? We have 5 volt. Yeah, we have 5 volt. Okay, let's see. Okay, so now what we want to do is in order to resolder U8900, we will have to reflow it just a little bit. Okay, but before we do that, something that I saw. I'm just gonna show you guys what I saw. U7300. So I see. Okay. So at U7300, this which is for which is a DD-Rec for the RAM. Now this test pad here seemed to be affected by a bit of oxidation, and if that's the case, the line between R7315 and C7315, that line will be broken to U7300. So let's just quickly open the schematic and to get a better idea. 820-3332. So that's U7300. U7300. Okay, so here it says DDR3 one V5 R 1V535. So it's basically 1.5 volt and 1.25 volt S3 regulator. So what we currently have in now, it's so if we see the pin 6 of that chip, let's say the pin 6 of that chip, this here, which is our so VREF, which is a voltage reference, 1.8 volt DD-reg, that will go to our resistor here, R7315 and R7316. Now, the test pad, it's a test pad that we saw. I'm going to show you guys that. If that is broken, there will be no communication between. So this line, it's not, there will be no communication between the chip itself and the rest of the sections, which is R7315, R7316, and also C7315. So we are talking about this part here, this one. So here, you see that it looks small, but that's the problem. So what you want to do is you want to, so yeah, see that. Let's try to see if we still have communication on that line. Okay, so uh, that pad is broken. That pad is broken. We need to. Okay. Before we address that, let us see. Let's see what rails are present on the board. So let us go to page one. Go to page one, and this is basically a list of all the pages on the schematic. Let us locate the page for the power rails. Mm, page for the power rails. Page seven. Okay. Page nine. Okay, yeah. Page eight. So eight, which is power aliases. That is where we want to go to. Let us go to eight. So we go to page eight. That will give us a list of the power rails on the schematic. Let us see. Yes, we already know that we should be missing. We're having a problem at 7300. However, let's get an idea of of what is happening on the board. So okay, Now, G3H rails, those arrays are going to be always present. PP3, PP person underscore G3H, we have confirmed that that rail is present. We confirmed that at the fuse is here, and then we got 12.6. So that's fine. Let's move on to PPV underscore S5 underscore HS computing ISN. That should be present, but let's just confirm that. So what we do, we just copy that line, paste it on our board view, and then we search. And then we search to see where that is present. So on the other side of the board, this caps here. We can measure that here, this line here. So let's say we're very sure that that's going to be present. That's at 12.6, that is fine. And then the next thing we want to check, it's PPV, that's the same thing. We pretty much, if this is present, then this should also be present. This is the same thing. Now, this is PP 18V5 DC in. This is the DC in voltage, so we don't have to worry about this. Why? Because we have PP pulse. I mean, if we had an issue here, we would not be having our PP pulse voltage. So this is the power rail that comes from the charger. PP DC in underscore CON. So that is the connector. So PPDC in connector. So that is the voltage that comes from your charger. And so this and that, we don't have to worry about that. Now PP3V42 is definitely present. Why? Because we have LED on our charger. If we didn't have LED, if PP3V42 was not present, PPDC in also, PP bus is also not going to be 12.6 because the SMC requires PP3V42 needs to be present in order for the SMC to be able to basically allow PP bus to go to 12.8 instead of 12.2, 12.3. 12.6, sorry. So instead of 12.23, you get 12.6, and that is because PP342 is definitely present. Now, here it says 12.8, but it's usually 12.6. I'm just going to show you guys that. So see that, it's 12.6. Okay, so PP342 is definitely present, but just for the sake of it, we copy that. Same thing, we copy and then we paste on our board view. It will show us where PP342 shows up on the board, and then we can measure that. So these are all of the areas where you have PP342. So we can measure, we can just check that at U5010, which is SMC reset. So we can check that here. Okay, we can check that here. 3.4. So yeah, that is present. So the next thing we want to do is so PP3V42 translates into all of this. So it's equal to all of this. So we don't have to. So if this is present, 9 out of 10, all of this will also be present. Now, PPVRTC. So that is the clock. That is the clock rail. So that let's confirm if that is present. Because of the issue that we're having on this board, that is definitely going to be present. So let's just see. So we do the same thing. We copy and then we paste on our board view, and then we search. Then we see where that rail shows up. So U2600, that is the clock generator IC. So that generates the voltage is required for the clock. So we can measure the voltage at C61, C2610. So that U2600 is going to be this. That's the clock chip, and that cap we can measure our voltage of which is the PPVRTC, which is going to be 3 point something volt. Let's see if that's present. And yes, 3.3 volt. It is present. So the next thing we want to do is we want to go our 5 volt rails. Let's see if our 5 volt rails are present. We did confirm that before, but just for the sake of it, we copy and then we go to our board view. We paste that in and then we search to see where that is present. So we at U7201 create our 5 volt. So We can measure that at C7205, which is here. This one here, we already checked that, and then we have our 5-volt present. So the next thing we want to do is we want to see if our 5-volt source line is present. Let's quickly check that. We copy the same thing. We go to search part, and then we paste, and then let's see where it shows up. It shows at Q7840. Q7840, it's going to be mm, the side of the board. Okay. Okay, Q7840 is going to be this guy here. This is going to be Q7840. Beside it, we can measure a 5-volt source on the cap beside it, which is C7840, which is this one here. This one here, and that is present. So 5-volt line is present. The next thing we move on to PP5 volt underscore S4. Let's see if that is present. Same thing, we search. Okay, let's try that again. Let's try that this one, yeah. Copy from here, not from there. So when you see reg, so basically that is where, so reg will mean where it's been, basically where it's being generated from. So we can check that at C7861. Let's see that. That's gonna be this guy here. This guy here. We can, and then we can check that at C7861. Let's see if we have voltage there. And yes, we have voltage. So and then PP5 S3 that we can check here. Copy that. Same thing, we search. And let's see if that is present also. That we can check here, which is this guy here. And we can measure for that voltage at C7850. C7850, this one here. And that is present. So one thing I can say, pretty much every of the rails will be present except the only place where we have issue, it's going to be U7300. So let's see what we have. Let's see 7300. So basically pin 1. Okay, let's not worry about pin 1. Let's see what we have on pin 2. Okay, above our RAM chips is going to be U7801. Let's see, do we have one? So do we have 1.5 volt there? Check here. We have 0 volt. So I'm just gonna go back to E7300. Let us start from the VLDO EN. So let's see what we have on pin 2 and then pin 12. Let's start to see what we have there, pin 2 and pin 12. So pin 12 is supposed to be 5 volt. Let's see. And open this here. So open up the battery here. It is a dash 3. Okay, we are busy with the 7300. Okay, so let's see what we have on our pin 2. Pin 2 that you can measure here. We have voltage on our pin 2. You can measure this cap here. 0 volt. Okay. And then let's see what we have on pin 12. Pin 12 we have 5 volt. Okay, so that is fine. Let's see, and then the next thing we want to do is let's confirm. Okay, our enable VTT enable, that's going to be at pin 17. Pin 17, let's see, do we have the enable signal present? Let's see, do we have enable signal present? We can measure that at R2810, which is going to be this one here. And what do we have? We have 0 volt. Okay. Let's see. And then yeah, let's see pin 16. What do we have? Do we have it present? Pin 16. We have enable signal present. Yeah, we have enable signal present. Okay, so the this is not going to be present until we address the broken via. So once that is addressed, then this can function 100%. Then we should expect to see the enable signal MEMVTTEN that will be present after that signal is being addressed. So let us now address that signal, and we should hope to have a working device. We can put a solder at that point of the board just to recreate the line that's broken. Okay, and put a small solder at that section of the board. I should I should I should do the magic for us. Get another one. Yes. Okay, so what you basically do is you're trying to put a solder in between, and
for pin 6 to communicate with the
pin 6. Yeah. So and also we be very careful not to just after that it's a ground pad. We don't want to bridge it. So we will check to make sure we don't have a short, and then at the same time we, we will also use that pin to make sure that we have communication between pin 6. So what we're trying to do is where's the line there? So this line here. So the voltage reference line, that is where what we're trying to rebuild. This is broken, and then so that's what we're trying to rebuild. Just check to see if that. Okay. Let's just make sure we don't have a short on that line. Okay, we don't have a short on that line. It's one way to confirm that that line is working is if we have voltage at the VTT line, which is this now, MVTT. Let's say if we have voltage there. Now, switch to voltage mode. Yeah, so now we have voltage there. So that tells us that now we now have a working fan should actually be on by now. Okay, you guys see we have a spinning fan. So just gonna we will clean that section of the board and add a bit of a coating to it. have an Apple logo. Find Spain. See if we have an Apple logo. Okay, that's an Apple logo, guys. And that's it. This is a completed repair. So we are not going to worry about U9800 because apparently U9800 is still fine. So, however, if you have a situation where the machine power is on, you even get a chime, but you don't have image on the screen, then U9800 it's the first thing you want to check, which is yeah, that's going to be the first thing to check. Okay, guys, that's going to be the end of the repair. I will see you guys in the next one.